Hello, future programmers. Missed me? Well, let's continue. Today, we need to increase the amount of gray matter in the enemy's skull. We'll do it gradually. So, the current task. The enemy opens its eyes wider, locates the player, assesses the distance along both axes, and chooses a direction to move based on the greater value. For example, if the distance along the x-axis is greater than the distance along the y-axis, then the enemy chooses movement along the x-axis. And if it's the other way around, then the enemy moves along the y-axis, constantly narrowing the distance to the player. To start, let's go to the enemy spawn branch and uncheck the repeat option on the on-timer block. We don't need an enriched crowd for now. One enemy is enough for writing and refining the algorithm. Let's go back to the enemy move branch. Take a look at this block. This is the final check. If it doesn't yield a positive result, it means all four boundaries have been checked and the enemy is on the game scene, ready to meet the player. From this point, you can power the entire remaining movement algorithm of the enemy. And the first thing the enemy needs to do is take a ruler and measure the distance to the player along both axes. I joked about the ruler. We'll have to recall our school years and determine the distance between objects using mathematics. Look. Here's the player. His coordinate along the x-axis is 1 meter. And here's the enemy. Its x is 5 meters. How do we find the difference between these two values? Well, let's try to find it by trial and error. For example, let's take the player's coordinate and subtract the enemy's coordinate from it. We get the expression 1 minus 5 equals minus 4. It seems to be true. And if we remove the minus, we get the distance between the two objects. If we swap the objects, nothing will change. 5 minus 1 equals 4. After the experiment, we make a solid conclusion. The distance between objects along the coordinate axis is equal to the absolute value of the coordinate difference. Let's fix this number in our memory. 4 meters. Now let's find the distance along the y-axis. The player's position along y is 1. The enemy's position along y is minus 1. 1 minus minus 1 equals 2. We obtain the distance along the y-axis between the objects, 2 meters. Now the enemy knows everything he needs. Now he must train his brain, compare these two numbers, and choose the greater of them. And if he succeeds, then he will know in which direction to shorten the distance with the character. Let's implement this part with code. For convenience, I suggest creating two local variables for the enemy. We will store the current distance to the player in them. Let's select the enemy, go to the object properties. In the armor props section, add two variables of the float type. Rename them to distance x and distance y. Now let's recall the formula we derived. Distance x equals the absolute value of the difference between player's x and enemy's x. So we simply take the math block, switch it to subtraction mode. Take to get object location blocks. Isolate the x-axis. In the first block, choose the player object. In the second block, leave the object field empty, so each enemy copy will return its own coordinates. We connect the coordinates of both objects to the subtraction. Now we just need to save the calculated value in the distance x variable using the setObject property block. We leave the object field empty again, as we will have many copies of the enemy, and each of them will have its own individual distance x variable. Let's add a red border to these blocks and label it distance x. Now let's copy this section of code and calculate the difference along the y-axis. To do this, it's enough to switch the cables to the y-axis. Let's write the obtained value to the y variable. Adjust the label. Now we connect these two blocks sequentially to the false channel of the last check. We won't see any visible changes in the game at this stage. But at this point, the enemy already knows the distance to the character along both axes. He calculated both values, wrote them on a napkin, and put them in his pocket. Now he just needs to compare them and choose the greater one. For comparison, we need a gate block, connected immediately after saving the values. Choose the greater operator. Take to get object property blocks and connect them to the two channels on the gate block. We specify the variable names, distance x and distance y. However, we need to compare the absolute values of the distances, so we need to pass the values through the absolute function. Regardless of the sign of the number, after this block, the sign will become positive. Well, there we go. Just a bit left. After the check, we have two options. If x is greater than y, then we'll move the enemy along the x-axis, and if not, we move it along the y-axis. If we run the game now, disappointment awaits us because the enemy will behave irrationally. This is because the enemy doesn't yet understand in which direction exactly it should move along the selected axis, whether in the positive or negative direction. We can now create a bunch of conditions based on the screen position to choose the movement direction. But I suggest doing it more elegantly. Again, with the help of mathematics. In fact, we already have the direction of movement. It is stored in the distance variables. We just need to understand how we can use it. Let's look at our code. 100 is a fixed value. It represents the enemy's speed. Let's say we are moving along the x-axis. If we need to move to the right, the speed should be positive. And if we need to move to the left, we need to invert the speed by multiplying it by -1. Now, let's look at this situation. The player is on the left. The enemy assessed the distance and understood that it needs to start moving along the x-axis to the left, meaning the speed should be negative. It just so happens that in our distance x variable, there is currently a negative value. It's negative because the player is to the left of the enemy, and the coordinate difference will always be negative until they swap places. And if they swap places, then the coordinate difference will be positive. So, we need to take the value from the variable and turn it into the number 1 with the current sign. Then we can multiply our speed by 1. If 1 is positive, nothing will change, and the enemy will move to the right. But if 1 is negative, the speed is inverted, and the enemy will move to the left. Now let's think about how to get 1 from a random number. The only way that comes to my mind is that we have to take this number and divide it by itself. Then, no matter what number we take, we will get 1. But our task is a bit more complex. We need to preserve the sign that was in front of the number. If we take a positive number, for example, 5, and divide it by itself, there are no issues. The sign was plus. In the result, we get a positive 1. But if we take -5 and divide it by itself, we again get a positive 1. The enemy will constantly move to the right. Let's not overload our gray matter today. I'll share with you the simplest way to preserve the sign at the output. Take the number and divide it by its absolute value. That's it. So, quickly before we forget what we realized, let's grab two vector blocks. Connect them to the vector channels, to the x and y axis. Connect to math blocks in multiplication mode to each axis. In the first field, enter the enemy's speed, 100th. Now we need to obtain one with the current sign. For this, we need to move math blocks in division mode. Connect them to the second channels in the multiplication. And you need to feed the values of the distance x and distance y variables to them. Feed the values to both channels and then complement the second channels with the absolute function. Well, that's it. Let's run the game and troll the enemy. Move around it and check its behavior depending on our position. If everything works as beautifully as mine, you can relax and take a break. Return to the enemy spawn branch and recheck the repeat option on the on timer block. Run the game again and try running away from the crowd. Let's tidy things up. Put the mathematics in a red frame. Label it. Movement in blue. Condition in green. Variable actions in orange. That's all for today. Take care. Goodbye.